Let us study what is mass. Mass means the amount of matter present in our body. For example, here I am taking one object. This object is made with the help of which all particles? The whole thing, we can say that is the mass of this particular body. So we can define it now. What is mass? Mass is the quantity of matter present in a body, or mass is the amount of matter present in a body. So here I am writing what is mass. First one, amount of matter present in a body. Amount, or I am writing as quantity of matter present in a body. Now at the same time I am explaining you what is meant by weight. Weight means weight of a body is the force which is acting on it. Which force? The force is exerting by the earth on it. So I am saying you, this object, this is having mass. On that, earth exerts a force. Both the things together will become weight. So weight means what? Force exerting on the body. Force exerting on the body. Who is exerting force on this body? There, earth is exerting force on the body. Here now force is exerting by the earth on this body. So we have got one distinguishing character between mass as well as weight. What is mass? Mass is the amount of matter present in a body. At the same time, what is weight? Weight is the force of earth exerting on a body. Now here mass will be there. We can write for mass, the symbol means for finding mass or the value of mass, m, that we can be able to measure in kilogram or gram or in milligram. The mass of a body we can measure in either kilogram or gram or in milligram. At the same time, we can measure weight by using a unit that I am saying you here. Weight of a body, that is W. W means what? That is the force exerting by the earth. Now, for measuring a unit of or a unit we are using for measuring weight, that is, we can say that same as force. What is the unit of force? Newton meter square per kilogram square. So weight means what? It is a force. Because of that, the unit of force and unit of weight is same. Now we can say that how do we find out the force of an object? For finding the force of an object, we are having one formula with us, that is mass into gravitational force. Same formula is applicable in case of weight also. So we can say that what is the formula for finding, or which is the equation for finding weight of a body? For finding the weight of a body, we can use the equation W is equal to mass into gravitational force. Now, if you are finding the force, we can use the same formula. What is that? Weight as well as force is same. So, formula for weight as well as mass is, weight as well as force is same. What is that? W is equal to F. The same formula then we can use for both. Let's see here, W is equal to force. Then for finding force we are having which formula? Mass into gravitational force. Same formula for W also I am using, that is mass into gravitational force. Now, as a result of the force exerting by the earth, the objects are falling towards the earth. Now we can say that, so towards which direction the object will fall? Towards the direction of the earth it will fall. So we can say that because of acceleration exerting by the, or because of the force exerting by the earth, there occurs acceleration on the body. As a result of it, the object falls downward. Now, another thing I am saying here, for mass, we can say that there is no necessity of thinking of the direction. So we can say that mass is a scalar quantity. Mass is a scalar quantity. Here when we study about the mass of a body, there is no necessity of any direction. Directly we can write its mass is 50 grams, 100 grams, like that. Now at the same time, when we speak about the weight, we can measure the weight with the help of direction. That means for studying about the weight, mass as well as gravitational force, both the things requirement is there. So we can say that weight, there means a gravitational force exerting towards the earth. So we can say that their direction is very important. So because of that, for this thing, which one? Weight is a vector quantity. Here mass is a scalar quantity. There only we people are considering its a magnitude. Magnitude of mass we are considering. We are not thinking of its direction. But at the same time, when we study about the weight, we have to consider towards which direction the object moves. So mass plus the direction is important. So we can say that here when we study about the weight, their direction is important. Because of that, weight is a vector quantity. Now another thing I am saying you, mass always remains constant. Anywhere we go, anywhere in the universe we go, either on the earth or on any other planets or on moon, anywhere we go, their all mass of the body remain constant. It won't have any change. But at the same time, here when we speak about the weight of a body keep on change. There will be changes will be there in the weight of a body in different parts of the universe. Suppose here our weight will be different. At the same time, when we go to moon, there our weight will be different. When we go to Mars, there our weight will be different. Why? Because mass will be same, but gravitational force exerting by Earth, other planets, all will be different. Because of that, weight of a body will be different depending upon the place or depending upon the location. Now we have to study about which one? Other point here, mass of the body never become zero. Mass of the body never become zero. Another thing what is saying, mass of the body never becomes zero. That means it can be 5 milligram, 10 milligram, 20 milligram, or we can say 20 kg, 50 kg, like that way, mass of the body never become zero. But at the same time, weight of a body can be zero. Then that how it can be zero? For that I am saying you one example. Now here, weight of a body can be zero, mass of the body cannot be zero. Now how weight of the body is becoming zero? Now you see here, weight of a body. Formula for finding weight of a body is mass into gravitational force exerted by the earth. Mass constant, it is not going to change, but at the same time gravitational force can be even zero. That is depending upon the height of the body from the surface of the earth. Either it is going deep into the earth or it is going above the surface of the earth. Depending upon that, it's a gravitational force reducing, finally it can be zero. as a result of it, if we multiply, suppose here gravitational force is becoming 0. Mass of the body, just imagine it is 50 kg. At the same time, gravitational force is 0. Then what will be our answer? 0. So here what is saying? Mass, weight of the body even can be 0. But at the same time, mass of the body never become 0. Then other example what we are going to study. Now, one thing I had already said, that means mass of the body. Now which all points we had studied? What is the definition of mass? Mass of a body means what? Amount of matter present in it. Mass is a scalar quantity. Mass never change from place to place. Mass cannot be 0. Again, mass we can measure by using different units like gram, milligram, then kilogram, etc. Now, when we study about the weight, weight means what? It is a force of attraction on the body. So, mass means weight means what? Weight is the force of attraction exerting by the earth on a body. Weight, we can say, is a vector quantity. Why? Because when we think of or when we study about the weight, there the force is very important. Force of earth is exerting on that body. Again there, which is important? Direction is important. When we study about the mass, direction has no value. But when we study about the weight, there we have to take the, or we have to give the importance of direction. Because of that, weight is a vector quantity. Now we can say that weight change from place to place. Why? Because the value of G keep on changing. G means what? This is small g means what? That is the gravitational force exerting by the earth. So the gravitational force exerting by the earth keep on changing depending upon the place. Now another thing what is saying, mass never becomes 0 but weight can be 0. Why? Because G can be 0. Then when we multiply the value of 0 with the mass, then we will get weight also 0. Now we have to study about value of G will be same in all places or not. So change in the value of G we are going to study now. Change in the, I am writing here now, change of G. That means a change in the value of G. Now we can say, now first we are studying about on the surface of the earth, what will be the value of G. Now just imagine children, the earth is not a perfect sphere. It is not a perfect ball like shape. Understand? It is not a perfect sphere. It is like an orange we can say. Just imagine orange, how it looks. Almost like that only the shape of the earth. Just to see. Just imagine how the orange looks. Upper part will be little flatter. At the same time, side part will be bulged. Similarly, our earth also looks. You see? Just imagine this is the center of the earth. This is the pole or polar region of the earth. Here also it will be there. North pole as well as south pole, south pole of the earth. Then this is the equator region of the earth. Here also equator region of the earth. So we can say this is the center of the earth. Now you see children, what I am speaking now, the value of G remain constant all parts on the surface of the earth or not? Answer is no. Every part of the earth, the value of G won't be constant. Why? Its answer I am saying. Listen children, from this part, here now it is the flattened surface. Here also a flattened surface of the earth. At the same time, we can see here projection is there, bulging is there. So the distance from the center towards here more compared to this part. We can say this is the radius of the earth, even this is the radius of the earth. Even then, there will be variation depending upon the parts or depending upon the surface of the earth. Why? Because here means the more bulging is there, at the same time here flattened surface is there. Because of that, the distance from the center to the pole is less. Here from the center towards the equator, the distance is more. As a result of it, the value of G varies. Now we can say, at the polar region, the value of G will be equal to 9.832 meter per second square. At the pole or at the polar region, the value of G will be equal to 9.832 meter per second square. But at the same time, the value of G at the equator will be equal to 9.78 meter per second square. So you see children, here now, depending upon the radius of the earth, but every part of the earth won't have same radius. That means from the distance to the circumference, at the equator one radius will be there. From the center of the earth to the circumference at the pole, the distance will be or radius will be different. Depending upon that, the value of G won't be same at the equator as well as at the pole. Even though, just see here, this is 9.832, here 9.78 is there. Approximately, we can take the value of G as a constant value, that is 9.8 meter per second square. So for calculation purpose, we are taking the value of G as 9.8 meter per second square. So we have no need of thinking of 9.832 will be in one place, 9.778 will be in another place. Like that, we have no need of thinking when we calculate any sums. So that particular time, we have to take the value of G, a constant value, that is 9.8 meter per second square. Now children, we are studying about other topic. Value of G will be different when it will be moving from above. That means from the surface of the earth. If it is moving above the surface of the earth, value of G again will change. So first we studied that on the surface of the earth itself, value of G is not constant. Now we are studying that if an object is moving above the surface of the earth, again its value is changing. How it is changing, I will say. Now we are studying about, here our earth is there. Just think. This is the earth. This is the center of the earth. Now, an object is moving straight from the earth. Just imagine, here now the height of the earth, the object is reached here. Here the object is there now. Again, the object may move again. Suppose this is first object. Now again I am making other object. This is lying at a height here. Now again I am making one more object from the earth. It is here. So depending upon the height of the object from the surface of the earth, the value of G keep on decreasing. We can say that Earth's attractive force is from its center. So earth pulls every object from its center. Now how much far and far the object is going, so for pulling them, Earth's strength will be little lesser and lesser. So we can say that now there will be means more height. Suppose from the surface of the earth 10 kilometer far, or we can say 20 kilometer far, etc. Like that all will be there. Even then the gravitational force will be constant. But I can say that above 30 kilometer, if the object is there, then the gravitational force exerted by the earth reduces. We can say that earth's gravitational force till 20 kilometer, till 15 kilometer will remain constant only, won't have more change. But once its height more and more beyond 30 kilometer above the surface of the earth, then we can say that it can be 9.77 meter per second square. Later again height if it is going, then again it can reduce from 8 point etc etc. Then like that way finally its gravitational force even can be 0 meter per second square. So we can say that from the surface of the earth, the objects goes how much height, depending upon that the value of g changes. On the surface of the earth we are taking a constant value. Even then we studied that at the pole 9.832 meter per second square. At the equator region the value of g is 9.78 meter per second square. Even then we are not counting such different values. We are taking one constant value for gravitational force on the surface of the earth, that is 9.8 meter per second square. Even though when an object like rocket, then that is going so high, so that particular time the gravitational force exerting by the earth reduces very low condition. That means the 0 point also can be. Now we can say that there are different types of satellites are there, weather satellite as well as communication satellites. These all satellites are going different heights as well as very much heights from the surface of the earth. Can be 400 kilometer above the surface of the earth, or some 35,700 kilometer from the surface of the earth. Like that way very heighted condition also satellites are going. So that particular time the value of g reducing. That means if it is 400 kilometer from the surface of the earth, that particular time the value of g reduces up to 8.7 meter per second square. Suppose weather satellite, if you are thinking of weather satellite, it goes 400 kilometer above the surface of the earth. Weather satellite going from the surface of the earth 400 kilometer above. Then there it orbits, that means it settles, then keep on moving around the surface of the earth. So that particular time gravitational force exerting on that weather satellite will be equal to how much? 8.77 meter per second square. At the same time communication satellite, that goes beyond that. It reaches up to 35,700 kilometer above the surface of the earth. At that time the gravitational force exerting by the earth will be equal to 0.225 meter per second square. So I feel means you understood now. That means as and when the height of the object reaches at different values, we can say that sometimes a less height may be there, more height may be there. So less height will be there, value of g is not going to change. That is also I can say that up to 20 kilometer above the surface of the earth, the value of g remain constant, that is 9.8 meter per second square. But beyond that if it goes, the value of g will have little variation. Then so much height if goes, then value of the g will have more change. Okay. Now with one more example I will I'll explain about the value of change of g. That means now we studied only above the height of the earth. Now I am saying if the object is going deep into the earth, what will be the value of g? Now one more thing I am saying you. If it is, now you see here, if the object is reaching 35,700 kilometer above the surface of the earth, the value of g reaches up to 0.225 5 meter per second square. Again beyond that, so much height again it goes. Then we can see that it can be even 0 meter per second square. Clear? Now I am going to explain about the value of G changes when the object go deep into the earth. Even the value of G changes from means 9.8 meter per second square to lesser and lesser, finally 0 if we go deeper and deeper into the center of the earth. With an example, I am going to explain that. Just imagine this is the earth, this is its center, this is the surface of the earth, here the object remains. Now from here the object is going deep into the earth. That particular time, just imagine the object reached here now. As a result of it, we have to consider that the radius of the earth also reducing at this instant. Now you see, once the radius reduces, even we can say that the mass of the earth also reducing. Now again, the object is reaching further till here. We can say that the object reached here now. Once the object is reaching here, we can say that here, or we have to think that the radius of the earth again reducing. Then further, we have to think that once the object reached here, radius reduced. At the same time, the mass of the earth also reduced. Now further, again the object is coming further and further towards the center of the earth. Again you see the radius of the earth reduced. At the same time, the mass of the earth also reduced. Now at last, the object reached at the center of the earth. That time, the radius became 0, even the mass also became 0. As a result of it, the gravitational force exerting by the earth is becoming 0. Now, with the formula, we will verify that. Gravitational force exerted by the earth is equal to capital G into capital M upon capital R square. Here, the mass of the earth at this instant I am saying you, mass of the earth is 0, radius of the earth is 0, only value of G will be there. As a result of it, we can say that the value of G will be 0 when the object reaches at the center of the earth. Thank you.